शायद मानस करूँ तमिस क्लिक अमिस बह ऑन कर हाँ अमिस वीडियो गई ना ऑन तमिस कर क्लिक हाँ
सर आप उधर मत जाया करिए ज़्यादा, वहाँ से आपका फेस ही नहीं दिखता है।
अच्छा नहीं बस पे थोड़ा था युग में कौन
नहीं शुनी ठीक
माने को मैं कहीं मार कर पूछ दिया ये क्या है फिजिक्स नोट बनाई है गुड सो अदीबा वेयर यू फॉर लास्ट फ्यू डेज बेटा वैसे लग रहा है चेहरे से लग रहा है बीमार है खुश गमस बेचारा ना ऑनेस्टली आई एम नॉट सेइंग हियर ओके यस्टरडे वी वर डिस्कसिंग कल हमने शुरू किया जरा ये ऑन करो बेटा is on okay so yesterday we were discussing the free electron theory. I have given the introduction to classical free electron theory and I told you that this classical free electron theory basically there are some outstanding properties of metals. What are the outstanding properties of metals? First, they have high electrical and thermal conductivities. Metals do possess high electrical and thermal conductivities. Then second was that in a steady state metals obey Ohm's law. Ohm's law is obeyed in metals, but it is not obeyed in semiconductors. Ohm's law is obeyed in metals but not in semiconductors. Ohm's law is obeyed in metals. I is proportional to E. Third thing that resistivity above Debye temperature. Resistivity above Debye temperature is proportional to absolute temperature. At high temperatures, the resistivity of the metals is proportional to fifth power of the absolute temperature. Then resistivity is inversely for some metals. Resistivity is inversely proportional to pressure. And the important thing is that Weidmann-Francis law is obeyed. What Weidmann-Francis law says? It says ratio of thermal conductivity to electrical conductivity is proportional to T, absolute temperature T. It is proportional to absolute temperature T. So that is known as Weidmann-Francis law. Then the other outstanding property of metal is basically for superconductors at absolute zero. That means as T tending to zero, resistivity is vanishing. Once resistivity vanishes, your conductivity will become infinite. Conductivity become infinite. Resistivity is vanishing because resistivity and conductivity is having inverse relation. resistivity, and because sigma is 1 by rho, your sigma is 1 by rho. If rho is 0, that means 1 by 0 it is infinite. That means your conductivity is approaching or tending to infinity. That is what in case of some metals which we call as superconductors. But problem with the superconductors is that it is very difficult to maintain superconductors at high temperatures. So no superconductor has been found till date that can exist at room temperature. You need this phenomenon exists at very low temperatures, around 4.21 Kelvin, when mercury shows no resistance at all. Okay. Then there are other phenomena involved in this. That is the expulsion of magnetic field, on the basis of which the magnetic trainers are moving. Magnetic leviating is a phenomenon while you are having the magnetic leviating trainers. Then there are so many securities. Then in the medical sciences, so many applications of these. So coming to the point that, see, as I told you that on the one side we are having a glass which allows some light to pass through. On the other hand side we are having the conductors like copper, like gold, like silver. Gold is the best conductor of electricity. But the problem with gold is that it is very costly. You cannot have electric wires made of gold. It is impossible. Huh? So it is a very costly affair. Then the second is the silver. Silver is also very costly. It's also a very costly thing. Silver is also a very good conductor of electricity. Then third is copper. So we are usually using copper, or for the transmission lines we usually use aluminium. Aluminium we are using because the problem with these conductor aluminium is that it is not transmitting all the power. Most of the power gets lost during this transmission from station to the from the grid to the station and then to our homes. Okay. So that is the problem with aluminium, these wires. Okay. But the problem is that what makes some metals to conduct electricity, and what makes the metals to be as opaque or to be as transparent like glass. So it was thought that there must be some theory. So Drude basically proposed in 1900 proposed a theory. It was Drude. He proposed a theory known as classical free electron theory. Classical free electron theory. What basically Drude said, Drude proposed, I guess if I remember the correct date, it's in 1900. Drude proposed in 1900 that metals consists of positive ions. Metals consist of positive ions whose valence electrons are free to roam among the ionic array. Okay, but the electrons are confined or restricted to move within the boundaries of the matter. But with restriction that electrons are confined to move within the boundaries of the matter. Within the boundaries of the matter. So this was very important point that Drude, he was the first person who formulated the free electron theory of metals. Drude was first physicist who proposed free electron theory of metals to discuss the electrical properties of materials. See, materials are having, some metals are having magnetic properties. You require a gas theory to discuss the ferromagnetic domains and the properties. So every metal, every property must have some theory behind. So was the case with this. So Drude proposed that free electron, classical free electron theory, in which he said that basically a metal consists of positive ions. You are having positive ions within the metal, and the valence electrons, they are basically they are roaming or moving within they are moving freely within this metal, freely moving within this metal, but they are restricted to move within the boundaries of the metal, just like you are having sodium. What is it, this number? Is it 11? So 8, 2, 8 and 1. 2, 8 and 1 is this electronic configuration. 1 is the valence electron here. 1 is the electron in the outermost shell. So these valence electrons within the metal, because your metal will be made up of some atoms. It will be made up of some atoms, okay? So the valence electrons of these atoms, they basically move within the material. They are free to move in any direction. No restriction so far. But the positive ions and the electrons, they are held together by electrostatic force of attraction. So your positive ions and electrons, positive ions and electrons are held together by electrostatic force of attraction. Electrostatic force of attraction. So when I say they are held together by electrostatic force of attraction, that means they are bound in some way. Okay? So, but these electrons within the metal, if this is a metal, the electrons are inside this metal, they are moving inside the metal freely in all directions. Whether you choose this direction, this direction, this direction, whatever direction you choose, they are moving freely like molecules or atoms of a perfect gas. Like, so that means again no interaction taken into consideration. Only kinetic energies are involved. Only kinetic, because we are not taking the interaction or the potential into consideration between these atoms. Okay? So electrons are moving freely. Electrons are moving freely in all directions. But like this very important point, like molecules or atoms of a free gas. If you are having gas, you can see in gas, they are moving in all random directions. Okay? In all random directions. Are you getting my point? So like molecules of these electrons are moving like molecules of a perfect gas. That means you are taking the ideal gas situation into consideration. Ideal gas you are taking into consideration. Okay? So, but these electrons stream into the direction of positive ion field. So now the question arises, how does the current generate? You know, current is motion of electrons. So these electrons, they are moving in the direction of the positive ion field. In the positive ion direction. Once they are allowed to move, they are moving in the direction of the positive ion field, they constitute current. That is what you call the motion of electrons or motion of charges. So they constitute current. And the other thing is that It was basically afterwards, it was basically what you call the Lorentz. Lorentz modified this theory. Lorentz modified free electron theory. That's why we call it as Drude Lorentz theory. Drude Lorentz theory. Drude Lorentz theory of free metals. Drude Lorentz theory of metals. So Lorentz modified this theory. Before coming to this point, see, if electrons are allowed to accelerate infinitely, electrons cannot, they are restricted rather to move, accelerate infinitely. So you cannot allow them to accelerate infinitely. So how to restrict their infinite acceleration? So that means, it is assumed that these electrons are colliding. These electrons are colliding with elastic ions. So these electrons are colliding with elastic potential, you call it as. So that way they are restricted to accelerate infinitely. This model has to restrict the infinite acceleration of electrons. Since electrons are moving randomly, because we are saying the most important conclusion of free electron theory is that in steady state it obeys Ohm's law. If they are accelerating infinitely, so then you can't have steady state. Are you getting my point? You can't have them steady state. So these electrons are restricted to accelerate infinitely by what you call the elastic collisions. Now what Lorentz did, he basically treated electron gas in terms of Maxwell-Boltzmann statistics. In other words, that means he has applied Maxwell-Boltzmann statistics to free electron model. So Lorentz is applying Maxwell-Boltzmann statistics to free electrons because the motion is random, and you were not having at that time the Pauli's principle. So you are not having what you call the Fermi-Dirac statistics that can restrict that can say your electron is basically a half integral space particle and it obeys Fermi-Dirac statistics. But we were treating here, it was the classical theory. Till this theory was discovered, we were having only the Maxwell-Boltzmann statistics. We were not having the quantum statistics they were not developed at that time. So we were using the Lorentz. He used basically Maxwell-Boltzmann statistics. In Maxwell-Boltzmann statistics, you always take random motion. It is fitted for ideal gas systems, while you are not having the interaction part is not involved. Second is that there is no restriction on the number of particles in a given state. So no Pauli's principle is applicable, because at that time there was no Pauli's principle. When this theory was formulated, there was no Pauli's principle. So what basically Lorentz did, he has basically neglected the attraction, the repulsion, mutual repulsion. Lorentz he neglected the mutual repulsion between the electrons. So you are having electrons, you are having an electron gas now. This metal is, your electrons are randomly moving in all directions, like molecules or atoms of a perfect gas. So he neglected the mutual repulsion of electrons. Electrons is negatively charged particle. They must have some repulsive force as well, mutual repulsion. There must exist mutual repulsion between them. But he neglected. This model neglects the mutual repulsion between the electrons. And the important thing is that the potential was assumed to be constant everywhere within the matter. And the potential was ionic potential. See, potential is constant. If potential is not constant, then this theory it is not valid then. So that was, in other words, that these were the limitations of this theory. Potential is actually it was assumed to be constant, which is not the actual case. So potential was assumed to be constant, and mutual repulsion between the electrons was assumed to be it was neglected by this theory. Keeping in mind this theory, so keeping in mind the limitations of this theory, still this theory explains many important phenomena, many important properties of metals. What important properties of metal is this theory explains? First is that in a steady state, Ohm's law is obeyed. Ohm's law is obeyed. Ohm's law is obeyed. That is, I is proportional to E. E is basically the field or voltage. So your Ohm's law is I is proportional to V. But in this electric unit, in this field, you can write I is proportional to E. I is proportional to E. So second important property that this theory is successful in explaining was that we call it as Weidmann-Francis law. It explains Weidmann-Francis law. That is, K by sigma is proportional to T. That is, K is your what you call the thermal conductivity. K is known as thermal conductivity and sigma is known as electrical conductivity. How much capable your conductor is capable of conducting electricity, how much your conductor is capable of conducting heat. If it is conducting heat, then it is thermal conductivity. If it is conducting electricity, then it is electrical conductivity of that matter. Okay? So K by sigma is equal to T, while K is thermal conductivity. K is thermal conductivity and sigma is electrical conductivity. Electrical conductivity. And third, in some metals, it was found that your rho resistivity is inversely proportional to square root of absolute temperature. Square root of absolute temperature. Square root of absolute temperature. So these were, despite the fact that this theory is having limitations in the sense that we are using classical statistics, that is Maxwell-Boltzmann statistics to free electron gas, which is not the actual case. Actually, this can be only explained when we take Fermi-Dirac statistics into consideration, because electrons are not ideal particles, they are a half integral spin particles. Their spin is half, so they are having, the Pauli's principle is there. There are so many quantum principles, quantization of energy is there. So you cannot simply explain this free electron model with the help of Drude Lorentz theory, because this theory is full of limitations. Despite the fact that it is full of limitations, it still explains these phenomena like Ohm's law is obeyed, Ohm's law it is verified. Ohm's law is not explained, is obeyed in case of the semiconductors, but it is obeyed in case of the conductors. Then you are having Weidmann-Francis law, very important law. So then it also gives us the information about resistivity. So these were the application for this. This was the importance of free electron theory. So before moving to quantum free electron theory, that may be the last question of your chapter 1. So I need to show, basically we got here the electrical conductivity. What this electrical conductivity is, how it can be derived, So let me try to derive this electrical conductivity, what it is equal to. No. Making habit of coming late. 10-15 minutes is okay, but not on several daily activities. So electrical conductivity. If tau is the time taken between two successive collisions, ठीक है, mu is the velocity in one direction. Stand up, move out. You stand up. Move out. If tau is the time taken between two successive collisions, mu is the velocity in one direction. And if the electric field on the negatively charged electron is E. Then from equation of motion in electric field, what we get? We know we are having F is equal to LA. But what is force? Minus EE. Minus EE is the force in the electric field. So M is, so I can write down M for A, I can write down d2x by dt2 is equal to minus E. Or I can write down d2x by dt2 is equal to minus E by M. So it is basically x double dot is equal to minus E by M E. Now integrating this equation, this is equation 1, this is equation 2. Integrating equation 2, what you get? You get x single dot. Because you are having double dot, when you integrate, it is left with only single dot. One dot and the one integral will cancel out. Because integral and the differential cancels each other. So x dot is equal to minus E by M et plus C. Because here in the integral you will be having dt. Inside the integral you will be having, it was like this. Integral of x double dot is equal to minus E by M dt. This is constant, it will move out. You will be having integral of dt. So this is your x dot. But the value of C? What is the value of C in this equation? So if T is tending to 0, if your T is 0, then obviously what will be your x dot? It will be your 0. हाँ, अगर हमारे पास T 0 है, x dot is dependent on T, that it is 0. Therefore, C is equal to 0. इसमें अगर आप substitute, if you substitute here 0 is equal to 0 plus C. It will be 0 is equal to 0 plus C. Therefore, C is equal to, because x dot is tending towards 0, T is tending towards 0 on this. Oh, that means this equation 3 becomes. Equation 3 becomes. Now, taking back equation 3 and substituting the value of C is equal to 0 in equation 3. So your x single dot will be equal to minus E by E, E by M, E, E by M, E T plus 0, that is no need to write that, okay? This is what we get, this is what we get after solving this equation, okay? So x dot, what this names an equation 4. Therefore, average energy, average between two successive collisions is given by x dot is. This is average velocity, sorry. Average velocity between two successive collisions is given by x dot bar. It will be 1 by tau minus E by M E T. Rather, it will be integral of this thing. 0 to tau, and this here it is dt. Here it is dt. So your x bar dot will be equal to minus E by M into E will move out into 1 by tau Inside you are having 0 to tau dt. T dt. This part is equal to tau square by 2. Integration of this is after giving limiters. First integration is t square by 2. Then giving the limiters for t is equal to tau. It will be tau square by 2. It will be just like this. T square by 2, 0 to tau. It will be now giving the limiters. Tau square by 2 minus 0. Okay. So your x dot bar will be equal to minus E by M E into 1 by tau into tau square by 2. Tau and tau will go. X dot is equal to E by 2ME and tau. But what is tau? Equation 1. See equation 1. E by 2m, it is lambda by mu. Magar mu is here the velocity in, mu is velocity. Because we know from mean free path how your tau is equal to lambda by mu. Because the molecules they are acting like the molecules of a gas. Perfected gas. We are assuming electrons like the molecules of a gas moving in random directions. So there must be some mean free path. That's why we are taking successive collision. The time taken between two successive collisions is tau, and mu is the velocity in one direction. You have already done it in your semester 3rd. So using here I have used equation 1 for this tau. Tau के बदले मैंने lambda by mu लिया, तो equation 1 को use करके. So let up this. down x dot bar is equal to, I will multiply and divide by mu. Multiply by and divide by mu. Minus E by 2m mu square. 2m नीचे भी मैंने म्यू डाला, ऊपर भी मल्टीप्लाई किया म्यू से, into lambda mu. Into lambda mu. Name this as equation 5, 6. Equation 5. Name this as equation 5. Now let us see what happens. So since we know that basically 3 by 2 kT is equal to half of m mu square. Your kinetic energy is equal to 3 by 2 kT. Your kinetic energy, because you are using the classical Maxwell-Boltzmann statistics. So you are using the ideal gas situation. 3 by 2 kT is equal to half of m mu square. Because your kinetic energy is 3 by 2 kT. Kinetic energy is half of m b square. Instead of b, we are using here mu. We are using here mu. See why? Because the mu is we are taking because you are always taking the averages. So because mean free path you cannot discuss in terms of the actual, because you are having always the, you take mean free path. So if suppose you take a smoke, in the smoke it takes a time for smoke to disperse. You are having smoke, a smoker is having a smoke. One is he removes his smoke from his mouth. You can see it remains for some time there, then it disperses. Why is that happening? Because there is the collision is taking place between two successive collisions. The particles are colliding. See, this particle is colliding with this and then moving in straight direction. Colliding with this, another two particles colliding, moving in this direction. So that is the mean free path. You take average of these paths. These free paths, after collision, the path traversed by the particle. You take mean average of that, you get mean free path. That's why 3 by 2 kT is good. That's why we are taking the average here. Average velocity or something like that. Half of mu square. Half of mu square. So 2 and 2 will go. 3 kT is equal to mu square. So that means x dot bar is equal to minus E by 2 is there. 3 kT. For this I am writing 3 kT. For this I am writing 3 kT into lambda mu. Into lambda mu. Or x dot is equal to minus E lambda mu. E lambda mu. E lambda mu. Okay. I suppose E square will be right. No. Minus E lambda mu by 6 kT into E into, or minus should not be there, it should be plus. It should be plus, somewhere we are doing the mistake. So you just check it out where after integration we should get rid of one minus there. Anyways, you check it out on the notebook, it's not a big deal. So what you are getting, your x bar is getting sigma E. Sigma, but what is the sigma? Sigma is basically E lambda mu by 6 kT and 2m is 6 kT. 6 is kT. This sigma is nothing, it is known as electrical conductivity. Electrical conductivity. Check it out somewhere, the minus should not come.